Welcome to Demography Today lecture series, sponsored by the BBVA Foundation and co-organized with the Spanish National Research Council and the LOMPOP Horizon 2020 project. We have the pleasure today to have Jean-Marie Robine, who has kindly accepted our invitation to be here in this summery day, almost incredibly hot day in Madrid. Jean-Marie is a research professor at INSERM, the French National Institute of Health and Medical Research, within the Thermes 3 research group in Paris, and MDN in Montpellier, where he has the research team in biodemography of longevity and vitality. He is also professor at the Advanced School École Pratique des Hautes Studies in Paris. He studies human longevity with the aim of understanding the relationship between health and longevity. In particular, he measures the impact that the increase in adult life durations may have on the health status of the elderly population. In his more recent work, he takes into account climatic change. He's as well founder of the International Database on Longevity and co-validator of the longevity of Jean Calmet, which is the oldest verified supercentenarian of all time. So thank you very much for accepting our invitation. As usual, we have around 1 hour time for the lecture, and then we will open the floor for questions. So thanks a lot. Thank you.
So tonight I will talk about the revolution of adult longevity. But before to do that, I would like to come back to a couple of papers published in the 1980s. And the first one is a paper of James Fries. It was published in the New England Journal of Medicine in 1980, and this journal is still today the most famous medical journal. And the second paper was published a few years later by Rove and Kahn in Science, and that time is not the best journal of medicine, but one of the two best journals just in science. And in fact, with these two papers, we got the conceptual framework in which we are still thinking today when we are thinking about the limits of human longevity, or when we are thinking about aging, what can be aging, how long we can live in good health. And with the paper of James Fries, maybe you know it, and the title is very well known, in Aging, Natural Death, and the Compression of Morbidity. First, we got this term, compression of morbidity, but also this idea of the rectangularization of the survival curve. This is coming from that paper. So it was published in 1980. In 1980, certainly James Fries had some data on the survival curve in 1900, possibly not to 100 years old, but okay, he was producing this first survival curve. And in 1990, so 35 years ago, we did not have the mortality data of 1980. So he was just guessing the shape. Maybe he had the data for the 1970, but he was guessing the shape and drawing the curve exactly also to 100, and showing this apparently strong rectangularization in the survival curve. And from that, he was proposing this ideal, absolutely vertical, rectangular survival curve, again reaching exactly the age of 100 years. But he was proposing this ideal rectangular survival curve as an horizon, something we will never reach, really the limits. So it was possible, in fact, for him in 1980 to move between the curve for 1980 and the ideal survival curve, but it was absolutely impossible to reach it. It was really something like we were aiming to, but impossible to reach and to go beyond, of course. And There is a second graph, less known, but also published in the same paper associated with this extremely rectangular survival curve. It is the distribution. The demographers are saying the distribution of the ages at death. But if you are working in biology or in biodemography, you will say it is the distribution of the individual lifespan. It's not really telling you at what age people are dying. It's more telling you how long people are living, and maybe it's more meaningful. So you can see here in this proposal of James Fries, almost everybody is still alive at the age of 70, 73 years. And people are dying in a very narrow time window, on average at the age of 85, and the first death, except very few, occurring at the age of 73 years, and the last one at the age of 100. So making us extremely homogeneous in terms of longevity. So this was the first proposal. So this paper was immediately accepted as very welcome by the scientific community at large, the medical doctors. James Fries himself was a medical doctor, but also by the epidemiologists, by the statisticians, by demographers, of course, and by the biologist. And Eflik is a very well-known biologist of aging. He was, maybe you know about the limits of Eflik. He did not get the Nobel Prize, but he was the one discovering that cells are dividing a certain number of times and then stop dividing, and they start to senesce. And but he was strongly backing the proposal of James Fries, and he was saying if we are able to eliminate all the impairments related to age, to aging, without changing fundamentally what we are biologically speaking. So at that time, we had discovered the genes and the code of the genes not many years ago. So people were really trusting in biological clocks, things like that. And for the biologist, the length of life was totally, fully determined by our genes. And for them, at that time, they were sure that if we were able to read the genetic code, we will be able to discover, to know how long each person will live. It was really written within your body. So for him, it was, if we are able to eliminate all aging-related diseases without changing what we are biologically speaking, we should be able to survive in full health until the last second of our life. And so it was really, and for him, it was really the limit proposed in this distribution I have just shown, exactly at the age of 100 years. And so it was like that, really opening the door to the next paper, which is important, is a paper by Rove and Kahn, published in Science in 1987. So they acknowledge in this paper what they call the revolutionary increase in lifespan. So it is this rectangularization of survival curve proposed by James Fries, and they said, so now the next step is to do the same, not for the individual lifespan, but for the individual health span. So we have to make totally rectangular the survival in full function, and for them it was really the new goal for gerontological science at large. So this is in the 80s. At that time, we had good ideas, And we are not hesitating publishing conceptual frameworks and theories, but we did not have a lot of data. But now we have a lot of data, but I'm not sure that today we are really willing to publish, to propose new frameworks or new theories. So we will come back to that, but looking at the actual data we have today. So I will start using some French data because we have quite good data in France, and I will show you, I will use the same years, but with real data. So I'm using the French woman data. Almost all the data I'm using are coming from the human mortality database, which is a fantastic resources, at least in demography and in public health, in actuarial sciences. So this is the situation in France under the mortality condition of at the turn of the century in 1900 is very similar to the one we saw proposed by James Fries. A strong decline right after birth because a high level of infant mortality, and this decline, but I don't know, it's really looking with real data, it seems that there is no many people alive under the mortality condition of 1900 at the age of 90 or above. And on the left panel, I'm immediately showing you what is the corresponding distribution of the individual lifespan. And here you can see that they are much less concentrated than the one proposed by James Fries. But we are in 1900. So in 1980, when the paper was published, but here again, with actual empirical data, this is a red curve. So you can see how effectively this is really giving the feeling that the survival curve in France under the mortality condition of 1900 is really rectangular, at least much more rectangular than the first one. We are not sure they are really ending at the same age, but okay, we can leave that for the time being. And on the other side, you can see the new distribution of the individual lifespan, and here it's clear that in fact already at that time the whole distribution of the adult longevity started shifting to higher ages. But nobody saw that at that time. And already James Fries was discovering with these papers, this rectangularization, and he was guessing about the possibility to have this very narrow distribution for the individual lifespan. This is a last available curve for France, so in 2014. You know, so even today I cannot give you the distribution of 2017. But at least the distribution for 2014 is available, and possibly in a few weeks, the distribution for 2015. But in 1980, I don't know, I remember, maybe, yes, there is something like 10 years gap to collect the data. Okay. What is interesting when we are looking at the green curve, I'm not sure the green curve is approaching to the ideal shape. I'm even not sure that the green curve is more rectangular than the red curve. Maybe it is exactly the opposite. Maybe the red curve is less rectangular. And maybe, in fact, it's just sliding now to higher and higher ages. And definitively, it's impossible to say that the three curves, the blue, the red, and the green, they are ending at in the same corner at the age of 100 years. And this, what we are observing, and now it's clear that in fact the whole distribution of the individual lifespans is sliding to higher and higher ages. And this is what we call the adult longevity revolution. So it's not just an issue of having more centenarians or having people reaching higher and higher ages, like the maximum age reported at death, is really the whole distribution, and firstly, the core of the distribution is moving to higher and higher ages. It's really concerning the whole population. And you can, it's clear that here, if you draw a vertical line, I don't know, you can do that at the age of 90, 95, or 100. You start with very small number under the mortality condition of 1900. Nobody is surviving to the age of 90 or 95 years. But then you see how quickly it's doing. It's going. So you will immediately see an exponential increase in the oldest people. And in fact, this is what is occurring. But just talking about the huge increase in the number of the centenarians, it's just talking about one age, when in fact this is occurring for all old ages. So this is what James Rees proposed in 1900. So now you can contrast the two shapes. It was not totally wrong. At least there is an optical illusion of a rectangularization of the survival curve between 1900 and 1980. But again, the green curve is absolutely not following the pattern of the ideal horizon curve. And the most important is effectively that in reality, the successive survival curves, they are not converging to a kind of fixed limit, at least since we are observing this longevity revolution. Ages are just sliding to higher and higher values. So I come back quickly on that, because I want to introduce two things. First is the males, because we're only talking about the females to see how it is. It's the same, but it's also different, but it's similar. And also because in France, we start having good data in 1916. Like that, I can add one more curve, an old one. And what is interesting here is when you compare the 1916 curve in blue and the 1900 curve, almost 1 century later, you can see that, in fact, almost nothing occurred during the 20th century. There is no change, basically, in the distribution of the adult individual lifespan. And in fact, if the researchers in medicine, in biology, in demography, in actuarial science in the 80s, they were thinking that, in fact, the longevity was almost constant. In fact, it was coming from the observation of the 19th century. With the beginning of demography and epidemiology, the first researchers, they were observing during the 19th century, and maybe until the World War II, a kind of stagnation in the distribution of the ages at death for the adult population. They were at that time much more interested by change over time in infant mortality, in premature mortality, but they were almost observing a stagnation in the adult individual lifespan, and from that they considered, or they just, that life was limited and there is nothing to expect in adult longevity. And the last thing I want to show you here is on this. So this is really what occurred in France from over almost 2 centuries in terms of mortality condition, is just to put on that the proposal of James Fries, which it's supposed to be the limit to the individual lifespan. And here we can see many things when we are comparing the actual distribution with a theoretical distribution. First, the actual distributions are much less concentrated. And in the distribution of Fries, 10% of the people, they had to die exactly at the age of 85 years. And in fact, in the French women, in the most recent, under the most recent mortality condition, 5% only are dying at the model age at death. And we still have a lot of people dying before this ideal distribution, because we still have a lot of premature mortality. But, and this is the most important for us, there is many people dying beyond the limits. And it's not marginal. And in fact, if you look at the model age at death at the French female in 2013, the model, so the most frequent age at death is beyond the limit. So it's not marginal, it's really the whole distribution is above. And the 2013 distribution is a very recent one, and we are not observing any kind of slowdown, so it's still moving. We are still in this revolution. We don't know exactly when this revolution started, possibly in the 1930s or in the 1940s, but you know it was between World War II and World War I, and there is also the big economical crisis of the 30s, so it's extremely difficult to say, okay, this started exactly in I don't know, in 1927, but at least, because now we are able to compute or to this kind of distribution year after year, for the time being, in the large countries leading the longevity revolution, in Japan for all the countries, in France for Europe, we are not observing any kind of slowdown. It's sliding to higher and higher ages. So just to summarize what I said, here I started again in 1916, going to 2014, with a curve by 20 years. Every 20 years there is a curve, and this is just, so because huge infant mortality at the beginning, it's difficult to see something, so it's just flattening, so we can just cut like that, and we can see better. And definitively, you see there is two groups of curves. Here, the infant mortality is very high, and then we have a very high premature mortality. But for all this curve, in fact, this is very interesting. If you look here, the model age at death is about at the same place. It's between 72 and 76. Between 72 and 76, and all this group of curves, they correspond to 1816 to 1934. So for almost, at least for 1 century, there is just a significant fall in infant mortality, a fall, but still some high level of premature mortality, maternal mortality, because we are dealing with the females here, but no big change in the distribution. And it is interesting to see that even this one is in 1934, almost everybody is dead at the age of 100 years. So they are effectively converging as supposed by James Fries. So this is, in fact, what we are supposed to have learned at school during the 20th century and the first half of the during the 19th century and the first half of the 20th century, an impressive fall in infant mortality, and this was just allowing more babies to die as old people, but no change in the schedule, in the time schedule of the old people. More babies becoming adult, but no change in the adult longevity. And then, after that, in the second period, so starting somewhere between 1934 and 1954, so before and after the Second War, the distribution of the adult individual lifespan started moving to higher and higher ages. And, okay, and again, so, and when you look here, looking at above the age of 90, it's really impressive. We can see that, in fact, during these centuries, we started from a situation where there is almost no people alive above, let's say, even 85. And now we can see that, in fact, for the females, the majority of them, they are surviving to 90 or even more, under the most recent mortality condition. It's not exactly the case for the actual cohorts, if we look at the history. So this, this accumulation of oldest old people, of nonagenarians and centenarians, have been acknowledged by some researchers, but this was not pushing them to contest, to challenge the conceptual framework or the limits proposed by Fries or Rove and Kahn. But and maybe the first one came from Paul and Margaret Boltest. They are very, very well-known psychologists. And Paul Boltest was running the Max Planck Institute on psychology in Berlin. And so for them, they are psychologists. Clearly, we were just accumulating, but they were not demographers, they were not epidemiologists, so there is no population thinking. They were just acknowledging this accumulation. There is too more, there is too many, there is a lot, more and more oldest old. And maybe they were the first one, maybe they were not the one to propose this new term, oldest old, but at least, and thanks to this book, they were promoting the use of this word, the oldest old. So they were proposing this idea that we have to stop to talk about the elderly people, like the 60s, the 65. There is people just so old now among them. And so their main contribution was to say we cannot keep this model of successful aging coming from the 80s, coming from Rove and Kahn, that was we can expect to live in perfect health until the day before our death. Saying, okay, maybe it was possible to think like that in the 80s because almost everybody was dead, let's say, before 90, but now we are accumulating so many people so old, and so the idea was you cannot live so long without losing some general capacity or some general reserve. It's just too long. You know, it's interesting because, again, they are not specialists in population science. They were not demographers or psychologists. So it was really, and so the idea is, living so long it's normal that you should have less reserve and you should lose some function. So having as a model, this model of successful aging, you have to survive without diseases, without impairments, disabilities, and to be fully engaged in the society is not working. You are just too old to do that. So they were proposing this model, which is very well known. This paper has been quoted more than 5,000 times. It's really the main reference in modern gerontology. They proposed a model called SOC, S-O-C, Selection Optimization Compensation. So the idea is, okay, you will lose capacity, so you have to select what you want to do, what you like to do, and doing that, you may be able to optimize your quality of life. So stop dreaming, keeping all the function of someone being 20 years old when you are 90 or centenarian, but through this psychological mechanism, you can optimize your quality of life even with reduced capacity and lost in a specific function. So they were moving like that from this absolute model of successful aging to a kind of relative model of successful aging. But they were not proposing nothing in terms of how long can we live, do we have some limits? So they were absolutely not changing the framework in which we are all thinking. But again, this paper was opening the gate, the door, to another one, published a few years later. So here, we were in 1990, and the next one was published in the Journal of Gerontology in 2001. So it's much more recent. And it's also a very famous paper published by Linda Fried, not James Fried, Linda Fried and her team, where she introduced the concept of frailty. And in fact, it is almost the same idea than the idea introduced 10 years before by Paul and Margaret Boltes, who were psychologists. So Linda Fried is a medical doctor in gerontology, in public health. And today, the concept of frailty is the core concept of modern geriatrics. And geriatricians all over the world, what they are trying to do today is to screen for pre-frailty or frailty, to prevent frailty, to try to bring frail older people back to some pre-frailty status. So it's really the core of the activity of the geriatrics of today. And this is a very new concept. And the idea is exactly the same than the idea of the Boltes. And in fact, she was observing that when you deal with old people, very old people, even if you know their disability status, they are disabled or not in terms of activities of daily living, you know if they have chronic diseases and how many and which chronic diseases they have in terms of comorbidity, even if on the top of that you know their age, in fact, is not enough. There is still something missing, and you don't know whether they are in a stable state. And if you are their medical doctor, you can just leave them for 1 week or 1 month, and you say, okay, when I will come back from my vacation, I will find them in the same state. So there is something in fact, what is missing is you don't know whether they are robust. If they are robust, they will stay in that state. Or if they are frail, what is the probability to move to another state quickly during the night or during the weekend or the week. And so working on that, she proposed, but she proposed just like a new concept, but it's not a framework, this syndrome of frailty as a decrease in some general physiological reserve, allowing people to face daily stress, small stress or big stress, whatever the kind of stress, just some reserve. And if you are losing this ability to face daily stresses, this will just increase your risk to have bad outcomes like fall, hospitalization, disability, or death. And this is something which is independent of, conceptually speaking, of comorbidity. Is not you have more chronic diseases. It's independent of your disability status. It's not the fact that you have more disability. It's independent of your age. It's just that on the top of that, or in addition of that, you have less reserve to face possible daily stresses, and this is, so it is exactly the same idea, is something that you are losing with the passage of time, so because you are getting old and older, so this is maybe the, and everybody was understanding the paper like that, if you live long enough, so it's exactly the same ideas and Paul and Margaret Boltes, independently of how many diseases you have, you will lose some reserve to fight all the health events you can meet in your daily life, and this will just put you in danger of bad outcomes in terms of health events. But again, she was not proposing a new general concept, new theories, new limits on our lifespan and our healthy lifespan. So back to what really occurred. So clearly, we got with what I was showing you much more oldest person. But here we have a new question which was brought recently, in 2005 or 2010, by an American demographer, John Baumgartz, which was contrary to, if you remember at the beginning, James Fries was saying, in the future, we will have an extremely narrow distribution of the individual lifespan around the age of 85 years. So we are living longer and longer in this rectangularization, but in fact, we are also living a more similar life, like nobody dying before 73 and everybody dead at 100 years. We know this did not occur, but we saw in France, in Japan, something like that. We reduced much more premature mortality than mortality among the nonagenarians. So we are more equal, if I can say, in terms of longevity. So he was just proposing, but looking at the American data, so maybe it's like that in the US, he was saying, I'm not observing this kind of compression of mortality when the model age at death is moving to higher and higher ages. what I'm seeing is that the whole distribution is shifting exactly by the same number of years. The core of the distribution, the model age at death, for instance, is moving by 5 years, but the maximum reported age at death, or the maximum lifespan, so really the tail of the distribution, is moving by the same number of years, 5 years. So it's really just sliding, fully sliding. And this is important. You will see why. Because when the core of the distribution is moving to higher ages, if the distribution is becoming more homogeneous, this will be like, will offset somewhere the emergence of the extremely old people. You know, if the tail is coming closer to the model, the mode of your distribution, this will limit the increase of the oldest old. And so this is, okay, I was cutting exactly at the age of 100 years because, okay, people are happy with that. The media, it's better to do that for just the centenarian. If you do that for the people 93 years old, nobody's interested. But centenarian is, oh, the media are very interested. So these 14 European countries for which we have data from 1945, they correspond more or less to the AU 15, you know, AU, so it's Western Europe. And altogether, we have very little centenarian in 1945, and you can see the increase is perfectly exponential. The number of centenarian in Western Europe, so including France, Spain, is doubling every 10 years. And here you can see that, in fact, here you have the male, the female, and the total. So when we are talking about centenarians, in fact, we are talking about females. For the time being, this population is made essentially of female. And from 1945 to today, this number was multiplied by 2 every 10 years. In Japan, which is a country leading the longevity revolution, you can see that, in fact, there is all the scales are the same. There is almost no centenarian in Japan in the 80s. And today, in Japan, there is more centenarian than in Western Europe. So things went much faster in Japan than in Europe. And here, we have really the two models. And we were more or less following the idea of freeze, of compression of mortality. So here, the model age at death is moving to higher and higher ages, but at the same time, we are more homogeneous around this mean. And this is like offsetting a huge increase of people in the extreme tail of the distribution. In Japan, they were more following the model proposed by Baumgart, and the whole distribution were sliding to higher and higher ages. And in that part, so during the 90s and in the first decades of the 21st century, the number of centenarians was multiplied by 3 or by 4 every decade in Japan. So this is, you know, just this moved in the distribution can reduce the increase in the number of centenarians from multiplied by 3 or 4 to just being multiplied by 2, which is already crazy enough, huh? You know, when you have a number multiplied by 2 every 10 years. So this is, again, this is what we are observing when because we have no more theories, or we have these theories published in the 80s and nobody was proposing to replace or to really challenge them. But observing what I was presenting for France or for Europe or for Japan. So, we observe this huge increase in the oldest old people. And when forecasting for the futures, we can get results like this one for England and Wales, starting in 2015 with 15,000 centenarians. Our colleagues in UK are forecasting in 50 years, so in 2065, to have almost 500,000 centenarians, and exactly 487,000 centenarians in England and Wales, including more than 7,000 people alive at the age of 110. And they got this forecast with what we call the central scenario. That is, if you keep everything constant, everything you observe during the last 50 years, the change in mortality, the change in fertility, the change in migration, say, okay, this is what we observed during the last 50 years. I have no idea, because nobody knows what the future will be. So my scenario is just, okay, what will occur to my country if just these things last for an additional 50 years? According to the British statistician, in this condition, they will have almost 500,000 centenarians in 50 years, including more than 7,000 people 110 years old. What is interesting here is that the French colleagues did the same thing about at the same time. And this is something recently published, but just updating what they did. And this is interesting because in France today, we have significantly more centenarians than in UK. In UK, today, they have about 15,000. In France, we have 20,000. So it's 25% more. Life expectancy is higher in France than in UK by 2 years. So we have more centenarians, we have a lower mortality, but with the same scenario, exactly the same scenario, keeping everything constant. So we will keep the change in mortality, in fertility, in migration for an additional, it's not exactly 50 years, but it's almost 50 years, 55 years or 54 years. They are finding 250,000 centenarians. So just, I don't know, but in France, people doing that, they are working with the French statistical office, INSEE. Most of them, they are coming from Polytechnics, which is the best advanced school in mathematics in France. So it's a very high level. There are big brains. In UK, it is exactly the same. So in ONS, in UK, they have also big mathematical brains. So they are properly working. We can imagine, guess. Officially, they were using exactly the same methodology, keeping everything constant, but they are really arriving to highly different results because, again, according to the British statistician, in 50 years, they should have almost 500,000 centenarians in UK, and in France, even a little bit further, only 270,000. And I think this is just, I don't want to say they are bad. I just say we have no framework. So we don't know what to do, what to think. And the numbers are just becoming so huge, so fast. Because keeping everything constant, keeping everything equal, in fact, the number of centenarians is really doubling every 10 years. And if you start, you can count on your fingers, if you start with 21,000 centenarians in France in 2016, and you multiply by 5 times at least to see what can be this number in 50 years, you will see that it should be much, much higher than 270,000. But I was talking with them to say, why you release this number? They said, because I think the key message is here. In the future, we will have just huge number of nonagenarians, of centenarians. If we were releasing the numbers given by the computer, people will just consider we are crazy, and we will lose the key message. So we are here. And in fact, of course, nobody knows what will be the future. It is possible that in the coming 10 years, this longevity revolution will stop, because maybe we are close without to know to some biological limits, but maybe not. Okay, so I don't know, but sorry. And I don't know whether you are following or not this issue, but recently a paper has been published in Nature when the authors claim that, according to their work, life is strongly limited, and in fact, the maximum lifespan is really, really close to 110. It's possible that some people, occasionally can reach the age of 115 or 16, but the possibility that a new Jeanne Calment occurred is almost impossible. It's saying that, in fact, again, like it was done in the past, maybe like James Fries proposing this limit at exactly the age of 100, saying no, we will be more on, everybody will survive to 70, but everybody will be dead by 100. And maybe it's a little bit the same, saying, okay, we have people reaching the age of 110 years now, but the limit is there. The limit is there. It's 111 or 112. And here, these are, again, the empirical number we got in France. So, and here you have the number of living supercentenarians in France. We are, for these people, we are sure of their date of birth and their date of death, if they are dead now, or the date of their anniversary when they become a supercentenarian 110. And so the first validated case occurred in France in the middle, of the 60s, in 1965. It was the first time in our population register we can validate, going back to the parish, to the church, finding again the birth record, having the birth record, the death record, and making a good validation of the case. Then we have to wait 10 years to see another one. And then maybe 2 or 3 years to have one, maybe 2 and 3, and no one. And then you see how noisy is this curve. But this is when the last time when I produced this graph in November, we had 35. So it's totally chaotic, but at the same time, it is purely exponential. And what is interesting is if we go back by 30 years, and we are not looking at the people 110, but we are looking at the number of people 105, we are getting exactly the same curve. The first cases occurred not in the 60s, but they were occurring in the 30s. And we have, at the beginning, it is exactly like that, except today, we have more than 2,000 people, 105, surviving in France. So we are at the beginning of an exponential increase. And so when we look at the data, it's just impossible to say the limit to the human longevity is around 110 when you have only occasionally one guy reaching that age, or when, in fact, now you have in the population 35% living at the same time at that age. And, we never saw, when we have in a room, in whatever the health status, if we have 35%, it's just impossible to consider that they will all die suddenly like that. And so more people, more time it will take for them to die. It's a mechanical. So there is no theories here. It's just the fact that, in fact, if we go back far in the past, not so far, we will find that there is no centenarian at all in our population. So they had no chance to reach a higher age than 100 years. Now, you saw the figure. We have 21,000 centenarians in France, so they will just live longer, just because they are more numerous. Do you understand? It's just a size effect. And this size effect was never taken into account by people proposing successively different limits. And they are not crazy, but you see, in England, the best statisticians, they are forecasting that in UK, they will have 500,000 centenarians in 2065, and 7,110. So in that case, you know, mechanically, we will reach higher and higher ages. And it's not just with this exponential shape. Okay, and so you understood now that one question is to know whether, when the model age at death is moving to higher and higher ages, whether the whole distribution is coming closer or not. And we tested that a few years ago. Here you have the model age at death, and here you have the mean deviation, measuring this distribution. And we were using, at that time, all the life tables available in the human mortality database. So it was almost 5,000 life tables. So here we have 5,000 couple. Starting, the oldest is from Sweden in 1751. And the most recent, they are here, for France, Japan, or Spain, whatever. And most of the points, they are here. And here, maybe 3,000 points are here. The model age at death is a little bit above 70, like in the Bible. And the mean deviation is about 10 years. So the most frequent age at death is a little bit above 70, but with a mean deviation of 10 years. And in the most recent data, the model age at death, but you can see there is very few points. Here it's Switzerland, Spain, France, Japan. The model age at death is above 90, 91, 92, and the mean deviation is 7 years. Or even 6.5 years. So on the whole, this compression of mortality occurred. The higher the model age at death, the smaller the mean or the standard deviation above the mean. But at the same time, the relation clearly is not linear. The relation is curvilinear. It seems that when we are here, at the beginning of the transition, when the model age at death was moving a little bit to higher ages, this was done with a huge reduction in the dispersion. And then the slope is becoming milder and milder, and suggesting that maybe if the model age at death keep going increasing, the mean of the standard deviation will just find a limit. And this is very interesting because maybe the limit is not for our longevity, but maybe the limit is for our homogeneity. We cannot just be 100% homogeneous, like all dying at the same age, like effectively a perfectly rectangular survival curve. So this is in all the work I done on empirical data on the human longevity. If we are approaching a limit, maybe it is a limit in terms of homogeneity. And the data is really suggesting that if the model age at death is going above 95, for instance, maybe we will not reduce anymore the variability between us in terms of individual lifespan. Okay, how long I can talk all the night? You told me it should be okay. So now I will go quicker. So now we are aware about this adult longevity revolution. With it, we have more and more nonagenarians and centenarians. The next question, are they in good health? Because if they are in good health, it's perfect, but we are not sure, and it is why we have this question. And again, this is very important. We are all in this adult longevity revolution, but not at the same pace. In some countries, and Germany is a good example, like Spain, like France, the increase is absolutely exponential, perfectly exponential, and the number of centenarians is doubled every 10 years. But in some other countries, and most in the Nordic countries, you see it's more linear. Like it seems that, and in fact, the speed of increase in the number of centenarians in Netherlands, in Sweden, in Denmark is really low. It is increasing, but compared to what we are observing in Western Europe, what we are observing in the north is and the two extreme here is Japan. You know, it's a number of centenarians is skyrocketing, and the one where the increase is the milder is in Denmark. So these are the two extremes among the countries where we have good data. And just this is the number of doubling every 10 years. So you see in Japan the number of centenarians every 10 years. If you look back for the last 10 years, the number of centenarians is multiplied by somewhere between 3 and 4. And in Denmark is always below 2. In 10 years, the increase is, let's say, something like 60% increase in 10 years. It's huge, but it's much less than a doubling. So, and these two countries are very interesting because it is the only places in the world when we have some information over time on the health status of the centenarians. And in Denmark, they have about 300 new centenarians every year at each successive cohort. So they started with a cohort of centenarians born in 18 1995, so becoming centenarian in 1995, a young geriatrics got as a PhD topic to go to visit all new centenarians in Denmark with a nurse epidemiologist and to make a geriatric assessment for all of them. So it's really like, okay, we have an epidemiological survey and a geriatric assessment of all the centenarians in Denmark. And they repeat that in 1905 and also in 1915 now. So they are monitoring like that by 10 years the cognitive status and the functional status of their centenarian. And this study was showing that 10 years apart, the centenarians surviving in Denmark, they are in better functional health. They have a better cognitive health and a better general physical health. And then they extended this kind of study to the nonagenarians. And so this paper is dealing with a cohort of nonagenarians born in 1905 and in 1915. So it's really extending, and they were finding exactly the same kind of results. So in Denmark, compared to the other developed countries, the number of nonagenarians and the number of centenarians are increasing slowly, but the new nonagenarians, the new centenarians, they are in better functional health, cognitively speaking and physically speaking. In Japan, where the increase in the number of centenarians is skyrocketing, they observe absolutely the opposite. In the 70s, when they had very few centenarians, you can see 37% of the female were confined to their room and a little bit more than 20 bedridden, confined to their bed. But in the year 2000, after 6 surveys, when there were already 13,000, you see now 78, almost the double, were confined to their room and more than 40% bedridden. So a huge worsening in the functional health status of the centenarians and maybe nonagenarians in Japan. The last paper I want to introduce to you, and I guess this one is really giving some keys to understand the future and what we have to do. It's a paper published again in the New England Journal of Medicine in 2010 by our colleague Gil and colleagues. They did something apparently extremely simple, but in fact extremely complicated to do. It's why we never published this kind of information before. They have been able to follow the trajectories of disability of people dying after the age of 70 years. And they are monitoring the last year of life. So every month, for 12 months before their death, they were having a phone interview with them to assess their level of disability. And imagine you are following someone like that, you call this person, or this person has some kind of disability, whatever, you call this person 8 times, and then this person dies. The work is lost because you don't have any information on the last year of life. Or you are following someone 12 months, but the person is still alive. So, and happily, at the age of 70 and above, the mortality level is not so high. So you have to monitor a lot of people who will die before 1 year And a lot of people, for 12 years and more, we will not die or not so soon. So you have to monitor a lot of people. So when they published their paper, so they are all, at least when they start, they are 70 years old. And about more than 400, between 400 and 500, were already dead. So they have observed the last year of life for about 450 people who died after the age of 70 years and having been followed at least for 1 year, monthly. And they find 5 clusters of what is occurring during the last year of your life. And look at them, 65, 76, 84, 91, 70, 67, about the same size. So it's really like each cluster is representing between 15 and 25% of the population. So they are, from a public health point of view, extremely relevant. They are not private, marginal stories. They are really mainstream stories. They are massive within the population. So we have here 5 massive trajectories within the population. So the trajectory we are looking for, the one published in Science in the 80s, it's this one. We have a small group of people, they die without disability. The day before their death, they were fully independent. For 1 month, this one, at each interview, they are fully independent for 1 year before dying. So they are perfect and they die. And then we got these second trajectories. 3 months before their death, they are fully independent. And then it is catastrophic. Their level of disability is increasing very, very fast, and they die. We have this trajectory 10 or 9 months before their 10 months before their death. They are fully independent, and then in 10 months, their level of disability is increasing progressively, and they all are ending with a very high level of disability. Here, you have to think about this like, the basic activities of daily living. So if you have one difficulty in terms of basic activities of daily living, that means you need the help at least to be watched or to be dressed, or to move from your bed to your chair, or to eat. So it is extremely severe. It's really what we are calling severe dependency. So here, the fourth trajectory, 1 year before their death, they are significantly disabled. We will say they were dependent, at least for 1 ADL, and then it's worsening and they die. And here you see the level is 3. That means they are all dying with a very severe level of disability, even if they got that level in the last month of their life, or in the last 6 months of their life. But the idea to die in good health for the time being is just concerning this one. And the last group, which is also representing about more than 15% of the population, they have an extremely high level of disability, between 3 and 4. That means they are almost fully dependent. They need help for almost everything. 1 year before their death. And then this is slightly increasing because they're at the ceiling, and they die 1 year later. Do you want to know what age they die, I'm sure. So the first group, they die at the age of, on average, 83 years. The second group, 82 years. They are a little bit younger. The third group, 84 years. The fourth group, 86 years. And the last group, 87 years. So the first conclusion, if you want to be successful in your aging trajectory, die soon or young. You know, the younger you will die, the higher the probability that you will be in good health the day before your death. And now, do you want to know what was written on their death certificate? Okay, this group of people, mainly they die from cancer, in that case at the age of 82, or sudden death at the age of 82.5. And the last group, the main mention of on their death certificate was frailty and advanced dementia. And at the age of advanced dementia is even at the age of 87 years. And when we compare here between 86.8 and 82.8, there is a 4 years gap. And so this is really demonstrating that the main model we have about successful or healthy aging and all the geriatrics medicine today is aiming at making you following this trajectory. But this trajectory, we never observe this trajectory like surviving until the last days of your life, being fully independent without disability. Yes, is what we're observing among people dying early with lethal diseases. And so it's, okay. So it's almost finished. So now, just one good news. And after that, we can discuss, because I said, well, one good news is also, this was published, paper published in New England Journal of Medicine in 2013. But during the last 2-3 years, we were getting much more paper confirming that, because in fact, we started running health surveys among the old people about 20 years ago. So now we have a follow-up, or we have time series for 20 years. And all the time series are showing the same thing. 20 years later, the old people, in general, they are just 65 and older, so they are not oldest old. But they have a much better cognitive functioning. And this is really good news. When we are repeating, and we did that in the United States, in Europe, in many countries in Europe, and all the studies are showing the same thing. If you started having a health survey among the elderly population 20 or 25 years ago, and today you repeated exactly the same survey with the same design, the results are showing that at the same age, so 65 or 70 or whatever, 85 years, the old people of today, they have a much better cognitive functioning than 20 years ago. So we don't know exactly why. What we are observing is the old people of today, they are much better educated. And in fact, we were talking about the education revolution among the young people, but these young people, they are ending by being old people. So now we have a kind of education revolution among the elderly people, so they are much better educated, and also they are better treated in terms of cardiovascular risk factors. So just to conclude, we have much more oldest people in our countries than expected, but it's easy to say because we were never expecting having old people in our countries, so this is really the big surprise. But, and this is important, there is a lot of disparities among countries. In this revolution, we are not going at the same pace. And gaps between Japan and Denmark, for instance, are impressive. And same, more healthy old people. Yes, it is possible, but specifically in the countries which are accumulating at a very small pace the oldest old. That means in the countries where the mortality level among the oldest old is remaining very high. So it's eliminating, in fact, and the oldest old. And more frail people, more demented people, no, surely not, because this is a good news. More demented, more frail people, this we don't know. We guess, but we don't know, because this concept of frailty is too new, so we don't have this 25 years chronological series. And in fact, if I just have to summarize with one sentence my lecture, it will be the overall results suggest that more people live longer, more difficult it is to satisfy the criteria of successful aging that we have decided to take 20 years or 30 years ago, at the individual level, as well as at the population level. So maybe it's time to change for the model of life we want to follow. Okay, thank you so much for your attention.